Okay, good morning. So as usual on Fridays we go through the homework problems. This is homework number 6, which is of course you know about trigonometry and similarity in general geometry. So let us read the first problem together. Ruben wishes to determine the height of a flagpole. This is your flagpole here in the picture. He takes a sighting to the top of the flagpole from point P. First, he is here. Look at the top of the flagpole, and of course, this angle of sight. This is called angle of elevation. Is 53 degrees. He then moves further away from the flagpole by 20 meters to point Q. As you see, he moves here 20 meters to the left in this picture and reaches to Q, and takes a second sighting. Of course, this new angle is smaller and 28 degrees. The information is shown in the diagram below. The height of the flagpole rounded to the closest integer is equal to, so you are supposed to find it and put the number here. Yes? I don't think this problem is hard, yes? Because we had something very similar to this problem before. So what should we do? Do you remember? It was very standard problem. We did very similar problem during the lesson. So if you don't mind, let me give it a name, A and H, okay? And my goal is to find the height of the flagpole. This is what I want. So what do I do? Do you remember something about this? So you know that the sine, cosine, and tangent only work in right angle triangles, and we have two of them here. One of them is here, and the other one is there. Okay, but there are sine, cosine, and tangent usually involved. You don't have the time to do trial and error, so you have to have a logic in the back of your head, which one is more suitable. Okay, either based on your experience you had before, or by way of thinking. For example, because you know that this is the unknown you are looking for, and this is opposite to these angles, so probably cosine is not that relevant here, because the opposite is related to tangent and sine. But sine is also related to the hypotenuse, which in this case we do not have any information about. So based on this logic, I'm not saying this is 100% correct, but this is at least a logic that gives you a feeling how to start. So probably which one is suitable for this problem? Tangent is suitable. I will go here, and in this right angle triangle, which triangle? Triangle APH. I can write tangent of 53 degrees, yes, is equal to the opposite side, which is the unknown H, divided by, unfortunately, the unknown pH. Okay? So let us keep it for the time being. And then I can write something similar in the bigger triangle, the triangle AQH, and I can write tangent of 28 degrees this time. Yes, this bigger triangle. Tangent of 28 degrees is the opposite side, which is again the unknown H, divided by QH, which is still unknown. Yes? But at least I know something about pH and QH. If I ask you how many unknowns you have here, how many unknowns I have? 3 unknowns. One of them is little h, the other one is pH, the other one is QH. And how many pieces of information I have? 2. So 3 unknowns, 2 pieces of information. You have enough experience about this, hopefully by now, that it is not enough. I need to look for another piece of information. But which piece of information I haven't used so far? I haven't used this value 20 yet. So how can I bring this 20 into the problem? It is very simple. QH minus pH is what? 20. So you write QH minus pH is equal to 20. Then I have 3 unknowns and 3 pieces of information. In principle, it is enough to answer all of them. Okay, but I just need only h. So I have to get rid of these two unknowns, which are not my target, in favor of this unknown that is my target. And hopefully from the lesson I told you, don't waste your time, you can always swap them. Okay, so pH goes there, h divided by tangent 53 degrees, and I can swap them as well. So this means that QH is what? H divided by tangent 28 degrees. Okay, so I go here, instead of pH, I put this expression, and instead of QH, I put this expression. So let us do that. So here I would write H over tangent 28 degrees minus H over tangent 53 degrees is equal to 20. Of course, some of the students are more comfortable to calculate this in the middle of the way, but do you see what is the weakness? If you want to do approximation in the middle of the way, the errors that we are making for each approximation will accumulate, okay? And it gives rise to an unnecessary big error. If you do it in the exam in that way, no objections, you still get the points, but I prefer you to try to do it algebraically because GeoGebra is available. It doesn't matter how complicated the expression becomes, you can just put it in the GeoGebra. But what is the first thing that I have to do? This h and that h should be factored out, yes? Because I need my unknown. And then when I pull h out, it becomes 1 over tangent 28 degrees minus 1 over tangent 53 degrees is equal to 20. A number, it's a little bit weird number, but that's a number. You can treat it as 5, 7, whatever. Times h is equal to 20. You are looking for h. You have to isolate your h by dividing by this fancy factor, yes? So h becomes 20 divided by 1 over tangent 28 degrees minus 1 over tangent 53 degrees meter. And that is the exact value. I mean, in the worst case scenario that you don't have access to neither calculator nor GeoGebra, you just write it like this and you get the full points. But now I wanted to also learn how to work with GeoGebra. So what I'm supposed to do, I need to go to GeoGebra and type this and get the number. But it is mentioned what? It is mentioned that I want to round it to the closest integer, yes? Okay, so now I go to GeoGebra and I want to type that number. So let me make it a little bit bigger here. What should I type? I should type 20 divided by, and then I have 1 over tangent, what? Tangent of, I press enter 2 times, and what is the angle? 28. By default, this is algebra view. By default, it is in degree mode, okay? So you shouldn't be worried about that. But in case if you need a degree sign, you can make sure that you can use a degree sign here as well. And then what happens? I go in front of it, and then I press minus, and then 1 over, again the same story, tangent, press enter twice, and then type my angle, which is 53, yes? And then if you want, I can put also the degree sign. Okay, so this is the answer up to 2 decimal points. So the answer is how much? 17.74. You can approximate it in your head to the closest integer. What will it be? 18, yes? But if you don't want to take any risks, you go here to setting, and then I change the rounding. Instead of having 2 decimal places, I will choose 0 decimal place. Okay, and then if you don't mind, we don't need this part that much, so let us get rid of it, and then we have this one. And by the way, because we don't need graphics, if you don't mind, let me just take that graphics out. Don't interfere with us. So that is the answer, yes? So what I will do, I will go to here and type 18 here. Any questions? Understandable? So this was not, this is an A-level question, but because it is very similar to the problems we already did, it should be very easy for you. Okay, any questions? Okay, I want you to think a little bit at least here until I prepare the board for the next problem. So the next problem is this problem. Configure the following figure. As you see here, we have a building. On top of that, we have a tower, and the information is given here. So for example, this length is 200 degrees, and these two angles are given. The height of the tower is wanted, rounded to the closest integer. Yes, so we want to find the height only of this tower based on these pieces of information. Okay, please start thinking about it. Okay, what do you think? At least you probably understand this is a problem on trigonometry, yes? Because right angle triangle is involved and some angles are given, one length is given, so you understand that this is probably not geometry itself, it is trigonometry. And in trigonometry, you know that we have sine. This is the way you have to think. Cosine and tangent. The first duty is to find which one is more suitable for this problem, because then we will be confused if we want to try everything. So what is your feeling? Based on experience you have so far, what do you think is a suitable choice? Sine, cosine, or tangent? Well, tangent, yes, because the angles are these angles. The height of the tower and the height of the tower and the height of the building are opposite to these angles. And on the other hand, I know about this, which is the adjacent at least to one of these angles. Okay, so this means that probably the one that is related to the opposite and adjacent is useful. If you have forgotten, you check the formula sheet and you see the formula for tangent is opposite to adjacent. So this is the first observation you have to make. Okay, because you also have to be careful about timing. And then, as I told you, if I want to give you this in the exam, I give it on paper. So if you want to do something, you don't need to redraw the picture again. You can save time. Okay, so to start naming something that it is easy for you. First of all, we know that this is the 90-degree angle. So the height of the building, so let us call it B, or the height of the building. And the height of the tower, so if you don't mind, let me call it T. Okay, that's a good name. And then if you want, you can also give names, yes, because it is on paper, you can write names on it with your pencil. So A, B, and C. Okay, we discussed about tangent is important. The first thing immediately comes to mind, if you don't mind, let me also give this a name. So I will start working in triangle ABC, which is possible because it is a right angle triangle. Yes? So what can I write? I can write tangent of 23.6 degrees is equal to the opposite side. Opposite is little b divided by the adjacent, which is 200. And immediately I can find the height of the building. So if the height of the building was wanted, I would say it is an E-level question, because that is fun, yes? I multiply everything by 200, so B becomes 200 of this tangent, then you type it in GeoGebra and get your answer. Okay? This is in meters. Yes, this is what. So this is the answer to the building height. But the problem is that this T is wanted. So what should I do now? Be careful, you are not allowed to work with this triangle, because this triangle is not a right angle triangle. Do I have any other right angle triangle? Yes?
You can add both the angles.
Yes, so I can work with the bigger right angle triangle, but I have to first calculate this angle. Yes? If I calculate, let me call this angle theta. So what is theta? It is not hard to find. It is 15.9 degrees plus 23.6 degrees. Do you agree? And then if I add them up, 15 and 23 is 38, and 1 comma 5, so it becomes 39 comma 5 degrees. This is the angle theta. And in the bigger triangle now, in the bigger triangle, meaning the triangle ABC, I can write tangent of theta, this bigger one, is the opposite side. But what is the opposite side? Can you give it a good name?
I have it.
Yeah, what? B plus T. Yeah, so I just write, that's correct. So 39 comma 5 degrees is B plus T divided by, again, adjacent side, which is 200. Yes? And now what happens? Okay, so from here, what do I get? I get B plus T. B plus T, I multiply by 200 again, so it becomes 200 tangent of which angle? 39 comma 5 degrees meter. This is also B plus T. Okay, again, I want you to learn. I want to repeat this so that you can learn. How many unknowns are there in this problem? How many unknowns I am facing here? B and T. How many pieces of information I have? Two. Two unknowns, two pieces of information. So I really don't need to do anything extra. I can start the algebra from here because it is enough. And it is very simple. What is my target? My target is to find T. So I have to get rid of T. I have to get rid of B. And that is very simple. B is this number. I take it with me and put it here. So what happens? It becomes 200 tangent 23 comma 6 degrees. This is B plus T is equal to 200 tangent 39.5 degrees. Yes? And I am looking for T. So I move this to the other side. So T becomes what? 200 tangent 39 comma 5 degrees minus 200 tangent 23 comma 6 degrees. Yes? And of course, if you want to make it more beautiful, what can I do? There's nothing I can do. I have to type it. But I myself prefer to factor the 200 out, yes? So even for typing, I need to type 200 once if I factor it out, okay? But that is not a have to, yes? You can do whatever you like as far as it is correct. So this is the answer to the problem that I have to go now to GeoGebra and type it and find the answer. Yes? So even it was simpler than the problem number 1, okay? But this was a little bit new. So we didn't solve a problem like this. So that is why I gave it in the home assignment so that you can also learn about that. Okay, so let us now go to GeoGebra. GeoGebra is here. Okay, so what should I type here? That number that you see on the board, yes? This number. And very easy, so I just type 200, open a pair of brackets, and I start typing tangent. Usually tangent appears like this. I press enter twice, and then it is ready to type the number. So 39 point what? 0.5, and I told you in algebra view by default is degree, but it doesn't hurt if you put the degree sign and then you come outside by the cursor keys, and then you have by the arrow keys, sorry, and then you type tangent again. Okay, sometimes it appears, sometimes it doesn't appear. If it doesn't appear, just type, it doesn't matter. And then 23 comma 6, and again, if you want to, I can press this degree sign. Okay, but be careful. I have already, if you remember, this is the same setup, so it is 0 decimal places, so that's correct. So the answer is 77. Okay, so then it's very simple. You just go here and type 77 here. Any problems? Understandable? Okay, so let us go to the next problem. This next problem is a little bit more challenging, so you have to be a little bit more creative here. So consider the following figure. As you see, there is a building and there is a tree here. From the top of the tree, if I connect these to these, I will have these angles, and the height of the building according to the problem is 150 meters. The height of the tree rounded to the closest integer is equal to how many meters? Okay, at least I want you to think about it a little bit until I erase the board and make everything ready so that we can start. Okay, might be it is a good idea to give you a hint for you. So I would recommend you to draw a line from here At least this is the way I think about the problem. Okay? A horizontal line, and then use the Z shape that appears. Yes, do you remember? We talked about the Z shape and the angles. Okay? This is my way that I want to pursue. But of course, if you are creative and find another way, which is correct, that's also okay. But instead of wasting your time, please start thinking at least what is a good idea and what is the good idea in order to solve this problem. Okay, so this is the picture, and that is the guiding line. I help you to do that. In principle, you should, if you have enough experience, it is not that hard to realize that this is very helpful to draw. Okay, but I gave you this as a hint. If I do that, okay, I draw this horizontal line parallel to the ground level, and then of course you understand that this should be also 90, this is also 90, yes? And then if the height of the tree, which I'm going to find, I call it h, do you agree that this from here to here also becomes h? But then what can I write for this one? The whole building height is 150. If, of course, you can call it another name, but it is not a good idea to bring different letters into one problem, because it means that you are increasing the number of unknowns you have. So you have to make the number of unknowns as few as possible. So yes, when this you call it h, don't call it x or y or something else. Because the whole thing is 150, when you call this h, this part becomes automatically 150 minus h. I hope that now you have this feeling that I have to work with this triangle and that triangle, okay? But I need angles. These angles are given. But we learned in geometry, not in trigonometry, that if you have a Z shape, means that these two lines are parallel, this angle and that angle should be the same. If this angle is given to be 22, you can understand by that theorem this is also 22. And there is another Z, not a correct Z, but hopefully you understand that this is also something like a Z. Okay? So this angle is 50, this angle is also 50. Okay, I also have my angles. But again, hopefully you know that still we need to use trigonometry, and always this is the question, which one we use, sine, cosine, or tangent. So have you developed any kind of feeling which one is suitable for this problem? What? Tangent is again useful, but of course, because this is a harder question, you shouldn't expect that everything is ready-made for you there. Okay? So if I want, for example, to use tangent 22 degrees, then it becomes the opposite side. It is not bad because it talks about my unknown. That's good. But then I have to divide it by the adjacent side. The adjacent side, it becomes this orange line, which I don't have it. Then I have to bring another unknown, unfortunately, in. So if you don't mind, let me call it, for example, x, because I don't have it. I am not sure that this will work. I want you to get used to this way of thinking. There is nothing clear. Even when I wanted to solve the problem and design, I didn't know that this method is going to work. The way that I am describing for you is the way that I think, and most of the time, if I have good experience before, it might work. If it doesn't work, of course, I have to cross it over and try to find another way. Okay, so let us try, at least. Because now you have also the good feeling, at least you told me to use tangent, so I'm using it. Tangent 22 in this small triangle is the opposite side, which is h divided by x. How many unknowns are involved in this problem so far? H is unknown, x is unknown, but tangent 22 is known because I can put it in calculator. So this is one equation with two unknowns. It is not possible to solve it. So I need another piece of information. Another piece of information is easy to achieve because 50 degrees hasn't been used yet. So again, I use tangent of 50 degrees. What happens? This becomes the opposite side, which is 150 minus h divided by, again, x. And in principle, if you are good in mathematics, you are relieved here. Why? Because how many pieces of information you see? 2. How many unknowns you have? 2. So it means it is enough. You don't need to look for anything else. The problem is essentially solved. If you have experience and you have listened to me, if you write this, you know you are on the you are on the right track, and you don't change your idea because it will work. But now it doesn't have anything to do with geometry. It needs your skills in algebra, because this is no longer geometry. We want to solve an equation and find the unknowns. So this is not a lesson in geometry. The whole problem is in geometry and trigonometry, but if you really want to solve it, it needs algebra. So that is why algebra is the first or the second chapter, because you have to know them in order to be able to solve the other problems. Okay, now technicality is coming. Okay, I know that I am on the right track, so how should I solve it? Which unknown you are looking for? H. X is unknown, but the problem is not asking about it. I am supposed to find H. So I have to get rid of X. This one needs experience in algebra. So can you see what can I do? Multiply by what? If I multiply by x, x will go here. If I multiply this by x, x goes here.
Factor out.
And then factor out what? Because there is no factor out. It needs a little bit of experience here. By the way, it's not that hard. Let me ask one question. If I divide 150 minus h divided by x, okay, if you don't, yeah, this is good. If I divide this by that, can you do it for me? If I give you this in the exam, in the second chapter, in algebra part, I give you to divide this, that's it. What do you do? Anyone else? Yes? Yes, exactly. So we know. But do you see why this is useful? Because now you copy and paste the first fraction, as we learned during algebra lesson. I change this to multiplication, and then h over x. And I told you then that there are some simplifications possible if you want to multiply. Vertical simplification, if it is the case, it is allowed. Vertical simplification, if it is possible, it is allowed. But cross-manner simplification is also, yes. Oh, yes. Thank you for correcting. X over x, that's the whole point. I have to swap, thank you. And now you can see that there is nothing that I can simplify in a vertical manner. There is nothing I can simplify in a vertical manner. Can I simplify this h with that h? No, be careful, this is 100 times. H is not a factor. Okay, you cannot simplify this h with that h because it is not a factor. They have been subtracted. Factor means being multiplied. But can I simplify this x with that x? Yes, so x to x 1, x to x 1. Okay, it becomes 150 minus h times 1 divided by 1 times h. Okay, so you see that this needs a little bit of experience, but the people who have sharp memory to remember them, they will be successful in the future. Because this was probably new to you, but now you say, aha, this is also one way to get rid of one variable. Because what happened? X is gone. So what I will do, I will divide this by that, or divide the other way around. So let me divide tangent 50, yes, and divide it by tangent 22, yes. And if I divide this by that, because this one is equal to this, and this one is equal to this, if I divide this by that, I can't keep the equality, yes? So it becomes what? This one divided by that one. Okay? First of all, do you see my logic? If this number is equal to this, and this number is equal to that, of course, when I divide this by this, it becomes equal if I divide this by that. And we already did this division. This means this divided by that. What did I get? 150 minus h over h. And I really expect you to understand, even in this case, if you are fast enough, you can understand that you can simplify these two. But I didn't use that because I couldn't count that if you know what I'm doing, so I did it the normal way. Okay? So what happens now? This becomes tangent 50 degrees over tangent 22 degrees is equal to what is left for me? 150 minus h over h. This is one piece of information, and how many unknowns you have? Just one. So in principle, you are in the lead. But do you remember in similarity part, I told you remember this very important, useful formula that if I have a fraction equals to another one, what can I conclude? This times that and this times that are equal. Yes or no? Okay. So this means that h times this, h times, I don't need pair of brackets, h times tangent 50 degrees is equal to this multiplied by that. So it becomes tangent 22 degrees 150 minus h. Okay? Many people, not many, some of you might get confused. You think that, oh, this is a very hard problem, but it is not. Why? Tangent 50 and tangent 22 are just numbers. Let us say this is 5, so it becomes 5h. Let us say this is 3. I don't know, but let us assume. If I give this in the exam, this is E-level question. Do you agree? How do you do that? You multiply this 3, it becomes 450 minus 3h, you move minus 3h to the other side, combine them and then divide. So if you can solve this problem, but you are horrified when you look at this problem, you have to fix something in your brain because they are of the same difficulty. Yes? But because you see tangent there, you might say, oh, this problem is hard. It is exactly the same problem, but these are just numbers. So I will do the same. So if you don't mind, let me write tangent 50 on the left-hand side of h. And as I told you, I multiply this in. It becomes 150 tangent what? 22 degrees minus tangent 22 degrees times h. Yes? And what I do? I move this one to the other side. Okay, try to help me, okay? So what should I do? The left-hand side is already tangent 50 degrees h. I move that one, it becomes plus, what is that? Tangent 22 degrees times h. What is left on the right? 150 tangent 22 degrees. Okay, help me now. We have experience now. What should I do with this combination? Factor h out. Yes, so if I factor h out, so try to overcome your feeling that this is a hard problem because you see tangent there, okay? Tangent 22 degrees times what? H is equal to 150 tangent 22 degrees. And now everyone knows what to do, hopefully. I have to isolate my unknown, so I have to divide by this weird factor. Who cares? Because the labor work is being done by GeoGebra. Okay? So, and then divide by tangent 50 degrees plus tangent 22 degrees. What I need to do, this is the exact value. In case you don't have access to calculator, of course I will give you. But in case you want the exact value, this is the exact value, but this is not useful for anyone except these crazy mathematicians, yes? If you are an engineer, this number is completely useless because you don't have a feeling how much is it, yes? In order to get the feeling how much is it, we go to GeoGebra again, and that setting is enough because we still want to do the same thing. So I want to type this number in GeoGebra, yes? So how should I do that? As usual. So because I want to put everything on the numerator, hopefully you have enough experience to open a pair of brackets, and I want to type this number there, yes? So 150, it's usually good to put a space. A space in GeoGebra means multiplication.
and then I press tangent. You see nothing comes in, so I type. Okay, I open a pair of brackets and I put 22. You know that the degree sign is not necessary, but let us get used to it. And then I go outside completely and then divide. And I type those numbers. So tangent, and it now appears. Press enter twice. And I put 50 degrees there. And then go outside. Plus what? Tangent 22 degrees. Yes. And the number that you get, you can see, is 38 meters. So you go back and type 38 meters here. Is that right? So it's a good combination of these techniques you are learning. I would consider this harder than the normal problems that we have solved so far. My goal is not to feel you stressed because of the exam or something. Forget about this, okay? Forget about the exam, try to learn. If you learn, there is no problem in the exam you cannot solve, I promise you that. Okay, any questions here? And you see that every time that I'm solving a problem, more or less, there are some sentences. For example, the pieces of information, the number of unknowns, I am repeating it over and over again. So this means that this is a good idea to have it in mind because I'm using it several times in this homework and I have done it before. So this means that this is essential to remember these things. Okay, so let us go to the next problem. This is also might be a little bit challenging for some of you. Consider the following figure. This is not a practical problem, apparently. This is just a geometry problem. It is not related to the buildings or trees or something like that. This is just a geometry problem. Consider the following figure. Rounding to the closest integer. We want to see what is x plus y. This height is x. Why I call it height? Because in the problem they have mentioned this angle is 90. Y is from here to here. And theta is this unknown angle. But can I assume that this angle is 90? Yes. No. Yes? If I am supposed to assume, they have to give it. And usually in the very standard exams, they say that the figures are not into scale. It means that you cannot guess. If they don't give this to me that is 90, I am not allowed to use it. It might be the case or might not be the case. We don't know. But we are not allowed to assume that because it looks like to be 90, it is 90. Yes? Okay? So this is why being an experienced teacher is good, because I could read your mind. Yes? I don't know. That was my feeling that some of you will answer yes, but this is no. Okay? So remember, don't use something which is not given. Because this one is given, okay? Because that is why we have some standards. For example, if in the exam you see this picture, you cannot say, Bob, I assume that they are parallel. Okay? Either I have to mention with English words they are parallel, or there are some conventions. Do you remember? Something like this. If you see something like this, yes, they are parallel. Okay, for example, might be you see something like this, and you see something like this. Okay, might be I put this one here, this one there, and I put double arrows here and double arrows here. What I am messaging you? I am messaging you, yes, you can consider these two are parallel, these two are parallel. Okay, this, if you see any indication of that by the convention, you can use it. Otherwise, you cannot assume that because it is similar to a 90-degree angle, so it is 90. Yes? Okay, so now you can think a little bit so that I can prepare the board, arrange it, and we do it together. Okay, so yes, I will draw the picture here. Okay, what happened? Do you have any idea? So let us go back to the problem. I want to find x plus y. In order to do that, I need x at least. And again, I told you before, if the question is hard, it doesn't mean that you cannot solve any part of it. You might be able to solve at least some part of it. So for example, here, I would say that finding x itself is an E-level question. And you see that? Why? Because on the left-hand side triangle, which is a right angle triangle, which one is suitable? Sine, cosine, or tangent? Sine. Because this is 38. Opposite to 38 is my unknown x. And this one is called the hypotenuse. So opposite is known, hypotenuse is also known. So it means that, opposite is the unknown, and the hypotenuse is known, and the angle is given. So this will be sine. So this one is easy. So let us do that one on the board first to see how it works. So in this triangle, so if you want, I can give them name A, let me call this H, let me call this B, C. In this triangle ABH, I can write sine of 38 degrees is equal to what? X over 10. I am looking for X, so I multiply everything by 10. So it becomes 10 sine 38 degrees meters. And keep it exact value until the very end that we want to use GeoGebra. So this is X and it is known to us. Yes?
How did you do it? X equals 10.
I multiply by 10.
Ah.
Yes, this becomes 10, 10 goes away, X becomes just X. Is that right? Okay. But now, is X known to me now? Even though it's a weird number, don't have this feeling I don't know X. We put it in GeoGebra later. So X is now discovered. And now can I use X that I know and find theta?
Yes.
The answer is yes. Again, in which right angle triangle? The one on the right. A, H, C. Sorry, what was that? BHC. Yes? BHC. What can I write? Which one is suitable? Theta is this angle. Opposite is known. Hypotenuse is known. Again, sine. Yes? So I would say sine theta is equal to x divided by 8. Okay? But what is x? X is this number. That the reason I want to keep it exact, because if I put it in GeoGebra right away, I make some error. If I take that one with me here and use GeoGebra to calculate theta, I make another error there. So I am increasing the error. Okay? In case, in the worst case scenario, if this is hard for you to manipulate this in that way, do it in that way. But I want you to learn the correct way. So what should I do? I would say that sine theta, instead of x, I put this number. You see, copy pasting shouldn't be hard. I just rewrite it again and then divide it by 8. This is at the end a number. Sine of theta is equal to a number. I am looking for theta. That was the last lesson in trigonometry. If you want to find an angle, you need to remember about sine inverse or asine. Yes, sine inverse, cosine inverse, tangent inverse in GeoGebra. In the exam.net calculator, asine, sine inverse, cosine inverse, tangent inverse. In some calculators and in GeoGebra, asine, cosine, tan, they are also in exam.net calculator. So at the end, what do I write? So theta is what? Theta is a sine inverse of that very strange number, but who cares? I just type it there. Yes, this is your angle. And it is in degrees, okay? Automatically. Okay, so now, by the way, you see in exam.net, because typing this is not possible, because the short answers, they don't give you access to the typing equation editor, so I have already put the degree sign myself there. You just need to type the number.
We need to type degrees in GeoGebra after writing 10 sine 38.
No. In GeoGebra, it is automatically, in algebra mode, it is automatically in degrees. Yes. So what I will do, but I want to teach you something in GeoGebra. Hopefully it will work. So let us try to test that. Because typing is also sometimes hard. So let us not type that much. So what I want to do, I introduce X to GeoGebra, but don't use letter X. Letter X is reserved in GeoGebra for the variable. Okay? So even though here the letter is x, but don't use it in GeoGebra. For example, you can give it another name. Let us say A. Okay, so what I will do, I go to GeoGebra because I know that, you can't do it case by case. That is why I don't want you to do that. You can type it here and then again type it there. Instead of, and then for the next part of the problem, I still need x. So then you have to type over and over again. So if you want to avoid that, so what you can do is this. You can say A is equal, so don't write x. X is reserved for the variable in GeoGebra. I introduce this number. What is that? 10 multiplied by sine of 38 degrees. Okay? And then I come outside and press enter. So this is 30, where is it? Why it went there? Okay, so if you don't mind, sometimes this happens. So let me reload everything. I don't want to get confused. So let us start from scratch again. Oh, I changed the setting, but I forgot to. So let me make it bigger. Save setting, come here. So let us do it again. A is equal to what? 10 sine 38 and then degrees. Yes, where is degree sign here? And then this, because I want to go around to the closest integer, I have to do this one. Let me save setting again. So I haven't. So A is this number, of course. A in our problem is which one? Is x. Okay, but the good thing is that now GeoGebra knows that A is that number. So whenever you type A, GeoGebra understands that what you mean. Okay, so you don't have to type it again. Okay, now let us go to find theta. Again, give it a name, for example. Give it B. Okay, you can also give theta, but let us give it the name B. I would say B is equal to what? How should I type it now? B is equal to sine minus 1, but I don't need to type that number again. I can just type A. Here it is undefined, don't care about it. Divided by 8, and then it becomes 50 degrees. So this is a better way. Of course, if you don't remember this, you can type again. But this is a more efficient way, especially because you are in a technique program. It's good to know about this. So the angle, but remember, this B is what? It's theta. So we found B. So in other words, I go here. The angle that I have to put, the only number that I have to put here is just 50, because I myself had put the degree sign up there for you. You just type 50 there. It's very minimal typing, okay? But now, x is already known. So my problem is to find y, because if I find y added to x, I am done.
But we have the angle, so it's easy to find.
This is one way. I want to solve it in both ways because I want you to understand deeper, okay? But let us go back to the board and then I want to wait for you, okay? One way to find this length, I'm sure that more or less everyone understands. Do you see that it is better to divide it into two parts?
Yes.
Because y is from here to here, and this bigger triangle is not a 90-degree angle, so it means that it is better to solve this part and that part and add them up. Okay? For doing that, there are two methods. One, a very, very famous one that you are familiar with even from grade school. So if you don't mind, let me give them a name. From here to here, let me write y part 1. From here to here, let me call y part 2. And then y that I am looking for is y part 1 plus y part 2. This is clear. But now, if you are in Grundschule, I don't know if you have studied trigonometry before or not, but let us assume that you didn't, but you definitely studied about Pythagoras theorem. Yes? X is known, is that weird number, is this one. And then 10 is known, so you can find y, y1. Yeah, so let us do that with Pythagoras theorem. So, then, can you tell me y1 squared is what? Be careful, y1 is not the hypotenuse. Hypotenuse squared is 10 to power 2 minus x to power 2. Do you agree or not? Okay, so which becomes 100. Do I have problems with x? No, x is this number, but type it later. So it becomes x squared. I am looking for y1. I take the square root. Do you agree? It becomes square root of 100 minus x squared. In algebra, we put plus or minus. Why don't I put plus or minus here? Because it is a length. It cannot be negative. Yes? So this is y1. Very easy. And what is y2? Similarly, yes? Do you agree? This one is y2. So y2, second part of y to power 2, can you tell me what it is? I want to use Pythagoras theorem again. A to the power of 2 minus x to the power of 2. But a to power 2? 64 minus x squared. So what is y part 2? The square root of 64 minus x squared. So the question mark in the problem, do you remember what was it? It was x plus y. But y itself is y part 1 plus y part 2. And x is x. Y part 1 is this one. And y part 2 is this one. Do you agree or not? You see, that is why I'm saying this method in GeoGebra is better, because otherwise you have to type this every time there.
But why did you put there an x?
No, it was in the problem, it was asking you about x plus. That's what I'm saying. The problem is asking you about this.
Okay.
The problem is asking about x plus y. Okay, so now I have to type this in GeoGebra and find the answer. Okay, but now you know how to type it, yes? I don't need to type that much because I have reserved. But do you remember what was the name of this in GeoGebra? A. So let us go to GeoGebra now. I come here, I type what? Help me. I want to find the question mark. X is A. Yes? Plus. A square root is under this default menu. And then what should I write? 100 minus A squared. Yes, I go outside, plus. No, be careful, I have to go completely outside, plus, yes. A square root again. And then 64 minus A squared again. The answer is 9. So the typing is minimal. Otherwise, you have to do this x all the time. This is one way of doing it using Pythagoras theorem. But can you solve this now using trigonometry again? And it is a very good idea if you can check with GeoGebra that the answers really match. Okay, so let me solve it in a different way with your help. So what do you think is good enough? Still, I want to find y part 1. I want to find y part 2. But if I want to use trigonometry instead, what can I do? Which one is suitable? So here, y1 is adjacent to this angle. Yes? And then you can use tangent if you want, because you already know x, but it becomes a little bit more complicated. It's not complicated because typing is just done in GeoGebra. But let us use cosine this time. Yes? Because if I write cosine of 38 degrees, can you help me? What is cosine of 38 degrees? Is the adjacent. What is the name of the adjacent? Y part 1 divided by the hypotenuse. 10. I am looking for y1. So y1 is just 10 cosine 38 degrees meters. So that is your y1. What is your y2? What is your y2? Y2 is, cosine of theta. Theta is not a problem because I know it now. Yes? Cosine of theta is what?
H2, Y2.
Y2 divided by 8. So what is Y2? Y2 is 8 cosine theta meters. So what is the question mark? The question mark is x plus y again. It becomes x plus y1 plus y2. X is x, but what is y1? Is 10 cosine 38 degrees. What is y2? Is this combination. Do you remember what was in GeoGebra? What did I call for theta? B. Do you remember?
Yeah.
Now I need to type this in GeoGebra. If I haven't done something wrong, the answers should be exactly the same. So let us test.
But I want to make sure that you know that. Do you remember when I wanted, let me, yeah, it is still on the, it is still here. Do you remember? B is that angle, theta. So what should I type here now? X is, what is in my notation? A plus, that is just typing 10 cosine, 38 degrees, yes? No, it's a cosine. That one, X is sine, don't get confused. And then plus 8 cosine of what? Cosine of B, 19. Yes? Do you understand that? Because B in notation in GeoGebra is the same as angle theta. I gave it the name B. So I type it, I get 19, I get 19. Yes? So both of them are correct if you want to do it in this way. Okay. Now let us go to the next problem, which is the last one. Yes? The last one is here. And then we probably will be done. So this is the only question I gave you here. I don't say that you cannot use trigonometry to solve this problem, but consider the following figure. AB is given, AC is given, D is given, then the exact length of BD is wanted. So AB, it means from here to here, is given to you 21 meters. AC from here to here is given to you 18 meters. DE from here to here is given to you 15 meters. And then what you're supposed to find, you're supposed to find this length. Okay? And then type it here. And I have written the units, so you just need to type the pure number here. Yes, please.
Can we please take a short break here?
No. This problem we will finish and then we are done. Okay, so how should I solve this problem? Preparing this board, you can also think about it. The idea, so by looking at the problem, what do you think this problem is related to? Which topic is that? Similarity, because usually the angles are not given. Of course, you can solve it using trigonometry probably as well, but my point to write this question was to use similarity to solve it. And whenever you want to use similarity, you have to justify why they are similar. One point of it will come for proving the triangles are similar. If you intend to use the similarity to solve the problem. But this is the first problem they are asking you about the exact value. Okay, so let us see how it goes. Okay, what happened? Because you see, I have done the information here. So from these blue lines that I have drawn here, you probably understand if this problem is supposed to be solved using similarity, which triangle should be involved? Because you need to have a rough guess about, because you cannot try everything, because you know that there is another pair of triangle here and there. And they are also similar. The bigger ones are also similar. But then this is up to you. You cannot just waste the time to trial and error to see which one works. Okay, so let me go here to tell you why these are similar as well. So, do you see that this triangle, which this doesn't have any name, but let us concentrate here, this triangle, and concentrate here. Just as an exercise, it's not relevant to the problem, but can you see that this triangle is similar to that triangle?
Yes.
But why?
Because they have 190 degree.
190 degree, yes, then it is not enough. Which theorem I need? Angle theorem. So 90 degree is one angle from one angle from the other one, but still I need another angle. So you are right. This angle that you see here, 90, is equal to this angle that you are seeing here, 90. But what about these two angles? Do you remember what was the name of these two type of angles? Vertical angles. So vertical angles are always equal. So two angles, one and one, another angle here and there, they are equal. So this small triangle that you see here and this smaller triangle that you see here, they are also similar. But you don't need to do trial and error, yes? You know that that is not useful for this problem.
because the information given to you is not related to the sides of this triangle and the sides of that triangle. Even though they are similar, but investing on them is useless. Yes? So then it means that I have to convince my teacher in the exam that these two are also similar. Are they?
Yes.
Yes, because again, this is 90 from this triangle. This is 90 from the bigger one here. But angle B is what? The angle in common, because it is shared between two triangles. So they are also similar. But you have to write it down if this is the exam. So you have to write it down. So I would say that angle, let me call it angle E1, angle C1, that's angle C1. So I would say angle E1 is equal to angle C1 equals to 90 degrees. Angle B is equal to angle B. I would write angle in common. Okay, but and then you do remember how to write in the exam. So for example, you say by what? Angle theorem. The triangle, name it. What is that? A, B, C is similar to triangle what? EB. Okay, this will bring you 1 point, or half of the, at least some points. This is somehow you have to write. And now, if you have good imagination, do it directly. We need to write the ratios. If no, you go to a scratch paper. You don't need to redraw everything again. But remember, keep the names. Somehow try to draw them outside from one another. So this is A, C, what? B. And the other one, draw it outside. So, but can you name it for me? What should I name here? E. What should I name? D. This one? B again. Thank you. But now you see this angle is equal to this angle. This angle is the same as this angle. So then the leftover should also be the same. Yes or no?
Yes.
Okay. And then I told you that you don't need to think that much. Write all of them. Decide which one you want to put on top. That is not important. For example, let us choose this one. So there are three sides, AB, AC, and BC. These are not important, which one you decide to put and in which order you want to put, no matter. But then it becomes important to be careful about what you want to write below. So AB is from here, opposite to 90. You go here, find 90, read the opposite one, is BD. Again, AC is a side opposite to one dashed angle. What is one dashed angle? Here, B. Opposite to it is ED. And if you want, you can write the other one as well. So BC is opposite to the two dash angle. Two dash angle is here. Opposite to it is BE or EB. And usually, by experience, you know that one of them is not useful. Okay, so let us see which information I have. Do I know AB?
Yes.
Read it from the, yes, 21. Do I know BD? No, that's exactly what I want. So this is needed. What about the next one? AC? Yes, I have it. What is ED? I also have it. So it is clear that I don't need any, and nothing has given to me. It is correct, but not useful. And I don't need more than that, because how many unknowns I have? One. And how many equations I need? One. And then I told you what to do. This multiplied by that. And before doing that, these numbers are a little bit big. Simplify them, okay? This 1 to 3 is how much? 6 times. This 1 to 3? 5 times. I don't want to confuse you. You can also simplify this by that. Okay, if you know that, do it. Otherwise, let us not to confuse you. So 6 times x is equal to what? 5 times 21. So what is x? X is 5 times 21 divided by 6. So I can simplify now. Okay, 6 by 3, 2 times. This by 3, 7 times. So 7 times 5, 35 over 2. Yes? Meters. They need exact values, but because this is numbers, you can write it like that. That is correct. But I would write it as 17.5 meters.
And that is exact value. It is not approximation. And that is why they have asked you to find the exact value. Any questions? Okay, so geometry, you have to practice to master it. But by the way, the examples in the book are not that simpler than the ones that I have given to you if you want to solve a B level and A level grades. But if you don't expect that, that is not that hard. Any questions so far? No?
It's very difficult.
Okay. So next week I will, of course, as I told you, I will design a new homework for you, and then we can do it on next Friday. Thank you.